Hi everyone! Today we are going to be learning about adding and subtracting rational expressions with like bases. So when we are looking at these types of problems, our goal is going to be to combine only the numerators and keep the common denominators just like you've been doing with fractions in the past. So as a recap, with fractions, if I had 1/4 plus 1/4, you add the numerators, but you leave the common denominator the same. So we actually have 2/4, and we can further simplify this to 1/2. We're going to do this now, but with rational expressions. So here's what I mean. Zoom in a little bit. So, for example, let's pretend I have n over 8 plus 3n over 8. I'm going to combine the numerators, the n plus 3n, to get to 4n plus 8. Because don't forget, there's a little invisible 1 right there. But once I add them, I can see that I can do 4 over 8 and simplify 4 over 8 to get 1/2. So 1n over 2. Let's try this a little bit more complicated with binomials. Let's say we have w plus 9 over 10 plus w plus 7 over 10. Denominators are the same, so that's our first goal, is to make sure the bottom denominator is the same. And now I'm going to add the numerators. I'm going to combine my w's to get 2w plus 16 all over 10. Now we can see that we can actually factor out and simplify this even more. So we're going to factor out a 2 from the top. Factor out a 2, w plus 8 over 10, and now I can simplify my 2 and 10 to get, that goes away, with a final answer, w plus 8 over 5. So far, not too bad. But what's going to happen when we have denominators that aren't just a single number, but instead denominators that are polynomials? That's when things get a little bit more complicated. Let's take a look at an example. V over v squared plus 5v minus 24 plus 8 over v squared plus 5v minus 24. First thing we need to do is to make sure we get a common denominator, which we do. But it might help if we actually factor it out just so that we can kind of see what it's going to look like. But let's combine things first. Our denominators are exactly the same. So I'm just going to rewrite it over here. V squared plus 5v minus 24. Add the tops, v plus 8. And you could be done, but maybe there's something else we can do right there. Maybe there's a v plus 8 hidden in this polynomial. So let's go ahead and factor. V plus 8 at the bottom. So we're looking for two numbers that multiply to 24, negative 24, but add to positive 5. We can do v plus 8, v minus 3. And luckily for us, those, v8s cancel out, leaving me with just 1 over v minus 3 as my answer. And we're all done. The only thing that we have to be careful for is when we are subtracting, because we have to make sure if there's a binomial, it goes to everything in that binomial. So let's do one more example. Let's take a look at 4n over 3n squared minus n minus 2. And I'm going to subtract it from n minus 2 all over 3n squared minus n minus 2. So denominators exactly the same. which is good for us. But now, let me go back. I'm going to do 3n squared minus n minus 2. But here's the thing. This minus sign is going to the n and the negative 2. So really, it's 4n minus n plus 2 because of the double negative right there. When we clean this up, we'll get 3n. Let me fix this 3. 3n plus 2. And now I'm going to go ahead and factor the polynomial on the bottom. Go ahead and pause this video and see if you can factor it all the way through. There's no GCF, so you're going to need to do your slip and slide method. Pause here, try it on your own. Hopefully, when you factored it out, you got 3n plus 2 and n minus 1. 3n plus 2's cancel out, and then our final answer is going to be 1 over n minus 1. And that's it for today's video. Now, for this entire lesson, we looked at adding and subtracting rational expressions with like bases. Coming up next, we'll be looking at how to do this when the denominators are completely different. Stay tuned for that video.